Welcome to the lesson Pair Sample T-Test. In next few minutes, I am going to give you an overview of pair sample T-Test. First, let me introduce pair sample. Here I consider two cases. Case 1. Here we consider a group of people and we measure the weight of each person. Now we have 5 observations of 5 people. This is our observation set of this sample. Again consider the same group of people and assume they are going to start a nutrition meal plan for weight loss. Before they start the meal plan, we measure their weight. And after a month of meal plan, we measure their weight again. Now you understand these two cases. First one, we have 5 observations and just one set of data from a sample. This type of sample is called one sample. The second case, here we have collected 2 samples. However, the measurements have been taken from the same group of people. You see that 156 become 166, 176 left become 170 left. It means for each individual, there is a corresponding observation in the second set of data set. So these pair of observations are called match pair or paired sample. It is very clear these two samples are highly related. Why? Because again we take 2 observations from each individual. Therefore, they are highly related. In other words, these are dependent samples. So, paired samples are dependent, not independent. Let me give you another example. Think about a students group who took SAT test first time and their grades are listed. Now, all of them are going to take a 1-month class. After the course, they take SAT again and second scores are listed. Again, 2 observations from each individual. So, this is also a paired sample and they are dependent. Now, let me give you a summary. We discussed we have 2 sets of data before and after from the same sample. And here we take first observation before and after from the first individual and second individual before and after. Similarly, you can continue. We assume there are n observations. And first observations before we use A1, A2, A3 and AN. Similarly, second observations after B1, B2, B3 up to Bn. So you see there are n observations of each groups. And population average of the before group we use mu1 and after group we use mu2. Then what is the next step? For our future calculations, we simplify this and we use a new variable. What is a new variable? We use di. Di equal ai minus bi. What is the ai? Ai is the observation of the before sample. Bi is the ith observation of the after sample. Now, let me find the d1. d1 is the a1 minus b1. That is first observation of before minus first observation of after. You see A1 and B1 coming from the same individual. Similarly, D2, A2 minus B2. You can continue for each observation up to Dn. So here I use before minus after, but you can use after minus before too. Either way, work. So now we have just one data set. What is the data set? D. D1, D2, D3, up to Dn. So these are the differences. Therefore, what is the population average of the differences? We know population average for the before set mu1 and after set mu2. Therefore, population average of the differences we use mu d equal mu1 minus mu2. Again, if you use after minus before, it should be mu2 minus mu1. Now we have one data set and we use this data set for our future calculations. Again, mu d, it is the population mean of the differences. Then we use xd bar, it is the sample mean of differences. How do we find the sample mean? Add these together and divided by number of days, which is n. That means d1 plus, d2 plus, d3 plus up to dn. Add them together, divided by n. Then sample is standard deviation of differences. So use these to find the sample standard deviation. Then we know sample error. Sample error is SD divided by root 10. In this case, we do some assumptions. Assume that the population distribution of the difference is cause is approximately normal. Yes, it is very similar to the assumption we did in my previous sections. Now let me explain the confidence interval for the true mean. Again, confidence interval for the true mean difference. So mu1 minus mu2, that is the difference. So mu1 minus mu2 equal what? Mu d. However, how do we find the confidence interval for mu d? It is xd bar plus or minus t alpha over 2 sd over root 10. You know all these terms, and t alpha over 2 is the critical value. And also, standard error of xd bar is sd divided by root 10. Let me explain this using an example. So we have a data set. Actually, we have two sets of data. First test 1 and test 2. How do we find the confidence interval for this data set? Use 95 confidence level. Yes, we have test 1 and test 2. As I explained before, we use the differences. Here we use test 1 minus test 2. So differences are negative 11, 5, negative 8, negative 9. So these are the D's our. D1 is negative 11, D2 is 5, D3 is negative 8, D4 is negative 9. Then we use these values to find the x bar, xd bar. How do we find xd bar? Add them together, divided by number of data, which is 4 here. It is negative 5.75. Then we need sample standard deviation of the differences. Then we use this equation and find the SD. It is 7.27. Now we already know the confidence interval for the difference mu1 minus mu2. Mu d equal mu1 minus mu2. Because here test 1, population average of the test 1 is the mu1. Population average of the test 2 is the mu2. Then we need degrees of freedom. Degrees of freedom is n minus 1. It is 3. Then we need to use the t-table. I explained in my previous video how to use t-table. Therefore, I just give the answer t alpha over 2, which is critical value, is 3.182. Now, we can plug these numbers to the confidence interval. So, it is here. Negative 5.75 plus or minus 3.182, then time 7.27 divided by square root of 4. So you can get 17.32, 5.82. That means mu1 minus mu2 value, which is mu d, is in between negative 17.32 to 5.82. Next, testing hypothesis for the true mean difference is 0. Alright, what is the first step for the hypothesis? As usual, null and alternative hypothesis. Before we go to the null and alternative hypothesis, think about this. True mean difference is mu1 minus mu2. So, true mean difference is 0 mean mu1 minus mu2 equals 0. That means mu d equal 0. Right? So, then what is the null and alternative hypothesis for this case? We can use mu d equals 0 versus mu d greater than 0. Or you can use mu d equals 0 versus mu d less than 0. The last one, mu d equals 0 versus mu d not equals 0. What is the next? Find the test statistic. What is the test statistic? Here we use T naught equal xd bar divided by sd over root 10. Before we used to see xd bar minus mu naught or something minus some number. Here also actually we use xd bar minus value of the mu d and h naught. What is the value of the mu d and h naught? It is 0. So that's why we don't use 0 here because it's just 0. Therefore we can write xd bar over sd divided by root 10. Once we have test statistic, we can use p-value. I explained one of my previous video. You can see how to find the p-value. Next, decision. Yes, H0 is rejected or H0 is failed to reject. So how do we check this one? We compare the alpha value and the p-value. The last one is conclusion. Now put the finding into the context of the problem. Next, find the p-value. Find the p-value for the right tail. How do we know this is right tail? Alternative hypothesis is mu d greater than 0. Therefore, this is right tail. We know we use the t distribution. Therefore, we consider the t curve with n-1 degrees of freedom and p-value is the area under the curve and right to the t naught. So, we can write the p-value is probability t greater than or equal t naught, right side area. Then left tail test, we know left tail because of mu d less than 0. Again we consider the t curve with n-1 degrees of freedom and now we consider the area under the curve and left to the t naught. So we can write the p-value probability t less than or equal t naught. Finally, we consider the two-tail test. So again, we consider the t n-1 degrees of freedom curve and negative absolute value t naught and negative absolute value t naught. And we consider this area probability t less than or equal negative absolute t naught and this area probability t greater than or equal absolute t naught. Now we add these two areas together. Two areas are the same because of symmetry. Therefore, we can find the p-value 2 times probability t greater than or equal absolute t naught. Now we go to the decision. How do we get the decision? Criteria for rejecting null hypothesis. We reject H naught if the p-value is less than or equal to the significance level alpha. Or other word, we can say we reject H naught if the p-value is less than or equal alpha. Alright, in my next video, I am going to discuss some problems. Thank you.